Okay, over the weekend, I got to grading your project designs, and I put stuff, I put some comments on every individual one when I saw issues or potential issues, and I want to just sort of review what I found in grading them. Here's kind of things to look at and possibly address. One is, I'll call it potential database issues. And what I would call a potential database issue is when I've looked at your database design and something didn't seem right to me. All right. Like maybe the relationship wasn't correct. Maybe you had it as a one-to-one and I thought it should be a one-to-many, or maybe you had it as a one-to-many and I think it should be a one-to-many going in the other direction. Or I look at the table and it's not clear to me the purpose of the table. Anytime I got confused about the database, I went by what I thought was the case, and then I put notes and then asked you for some input. So for some people, I said, can you write, a paragraph or two explaining the purpose of each table? So that way I understand what each table is used for and what the purpose is. And that would help me identify if the relationships are indeed correct or if the relationships needed working on. So note that in some cases I may have questioned a relationship, like saying this what you have is one-to-many. Should that maybe be a many-to-many? So if you had any kind of notation about that, I usually put in there what I would like you to do to clarify the situation. And at any rate, we should have a conversation on it because with this, getting the database right and getting the model right, I actually should possibly update this assignment to have you create the models first instead of creating the database. But they ought to be equivalent. So it probably doesn't matter too much which way. I figure some of you have probably, or all of you should have had some experience developing ERDs. So, you should be able to do that. But I guess my point is that where I thought something didn't look right, I assumed that I was correct. I took off some points and I asked for some clarification. And if I wasn't clear enough in terms of what clarification I wanted from you, then just ask me, like, well, what do I need to do to show you that this is correct? Because maybe you are correct. Maybe my understanding of the problem or my understanding of the tables is off. Or maybe I'm correct and the relationship I think should be a many-to-many really should be a many-to-many for whatever reason. So look at any comments I made about the database design. I'll tell you, while I checked the whole thing, my focus was really on the database design because a lot of the things can change if you have a solid database design sitting on top of it. And I'm saying database design because traditionally that's what it was. Really, we're designing the entity model. All right. And again, like I mentioned before, that's the implementation of it in a relational database is going to be the equivalent of that entity model. So if I took points off, there's a good chance it related to that. Other things I took points off for is if you omitted a section, like some people didn't include a prototype. Well, that's points off. In some cases, I took off on requirements or goals if I thought they were not really related to your project, but were just general web design guidelines. Like a requirement saying that the site should have a simple navigation, that's not a good requirement, all right? I mean, any site you develop should have a good navigation, right? I mean, that's not something special about your particular product that you're developing. So the requirements and goals should relate to the content, not the specifics of the interface. So I may have deducted some on that if I said it's vague, or if I said that's not really a requirement, that's probably what I mean. In any case, pay attention to the comments. It's not like the class collectively did a bad job on it. You did pretty well, pretty normal, as expected, but a number of you did get some points taken off here or there for things that I spotted as being wrong. And again, you're welcome to fix them. Up until the final drop dead due date at the end of the semester, you're allowed to fix any points that you have taken off on any assignment. Second thing I want to talk about is the proper scale. And this is tough as far as projects go. For a number of you, I probably said something like, consider scaling this down. If you had 10 or a dozen tables, well, that's probably too much, right? I mean, if you show me that you can create tables that integrate in a certain way, I don't need to see you do 100 times of it. You know, showing me that you can do it is enough. So if you had too many tables or too many tables with different relationships, I may have said consider scaling it down. Here's my criteria. What you do for the project ought to be one aspect of the problem that you're addressing and solve it completely. Like, I'll talk about an example for this when I get to the Contoso example that we're going to go over today. So make sure, you know, I mean, it's not my intent to, you know, cause you distress and develop a gigantic application. You know, just develop an application that does something and does something well and does something completely. All right. Well, it's not a requirement for your situation. It is a requirement for me grading. It ought to be user-friendly. By that, I mean you should not ever have to key in an ID number of a related table. So if you have something like we had in the homework where we had meals and the meals have a category, you should not have your screen, your input screen such that the user has to type in a category number, because users don't remember those things. It's not their job to remember those things. All right. And therefore you should give them a user-friendly dropdown to pick data from. Again, should be user-friendly in that regard. Think about the problem that you're trying to solve. Think about what you want to do, and think about how you would want it to work. If this is something you were using, how do you want it to work? And the focus ought to be on the output of the application or the system. We'll come back to, hold that thought. We'll come back to it in a minute here. Authentication. You have seen what we covered about authentication. There's no immediate plans for me to go over anything else about authentication. Therefore, if you're planning on doing more with authentication, such as having roles where one person might be defined as a user, one person might be defined as an administrator, and they have different powers, that's something that you will need to work out on your own. All right. Not to say you're totally on your own with it. I'll give you a hand, but it probably won't be covered in class. Again, depending on how time goes, it's possible I might cover some of it, but that's kind of on you to provide the impetus for getting that done. And again, I'll help you, but know that that's not a topic of the class that we're going to go into much deeper than we already have. Okay, focus on output. What do I mean by that? Well, we'll talk about data versus information. We're going to get very fundamental for part of this lecture. And I hope somewhere in your academic career that someone discussed the difference between data and information, because in just regular language, we use those two things as synonyms, as meaning the same thing. But from an information technology perspective, they mean different things. And data would be defined as raw facts. So, my company sold $100 million worth of merchandise last year. All right, $100 million worth of sales. That's a raw fact. Is that good? Should we be celebrating? Should I be looking into what went wrong? You don't know just based on that raw fact. You'd have to consider other stuff. So you'd have to put that in context. In other words, how many employees do you have? Let's just look. If I am the Ford Motor Company, Ford Motor Company had a revenue of $174 billion. So if the company I'm talking about was Ford Motor Company and they had sales of 100 million, they had a horrible year. All right, no way around it. Now, if that company is my side business of printing T-shirts out of my garage, and I somehow had $100 million revenue for the year, I probably did pretty good, and I'm probably celebrating. All right. So, how do you transform these raw facts into something usable? Something usable, by the way, is what we call information. Something that we can look at and gain some knowledge or take action. Gain insight. Let's put it that way. That's better than saying gain knowledge. Gain insight. Take action. So raw data is transformed into information. That is data presented in a way presented in context. Information is derived from data. But the data is somehow transformed to produce information. I'm curious, drop me an email, ask me, tell me if anyone has ever covered this with you, because I think this is an important fact. People out there, raise your virtual hand if this topic has been discussed in one of your previous classes. Okay, I see one hand go up. See a second hand go up. Good. Good. So this is a brand new review. But I am going to put that in context of what the meaning of this is for your project. It's funny, in the old days, using computers in businesses was called data processing. The focus was on the raw data. At some point, people decided that that's sort of putting the cart before the horse, right? what's really important is not the raw data that comes in. I mean, it's important, but what's the real benefit to an organization is the information that is derived from that raw data. So how do we transform that data? We can transform that data any number of different ways. In a sense, we're putting it in context. So we can transform data by filtering it. All right. What do I mean by filtering it? I mean, not showing every piece of data that exists, but showing data that meets a certain condition. Let's say I was responsible for accounts receivable at a company. Would I want to see everyone that has a balance with us? No. If I was in collections, I might only want to see the people that were more than 30 days late with their payment. All right. Because that narrows it down. That maybe I can do something with. Send out a mailing, send out an email, call on the phone, whatever, depending on the company and what the volume is. So a list of everyone and the money they owe you, it's sort of a dump of raw data. Filtering it out to show people that maybe owe above a certain amount of money and have not made a payment within X number of days past their due date, that's going to give me meaningful information. That's the people that I, as a collection manager, want to address. All right. So filtering data is one way that's done. Combining data. Getting back to my hypothetical company that sold $100 million worth of merchandise. Well, what were the expenses for the company? You know, what is their cost of all their employees' wages? What is the cost of their materials? What is their fixed cost, variable cost, all that kind of stuff that you learn about in accounting. So if you take that sales data and combine it with other kinds of data, then you're putting it in context. If we look at that and say, gee, $100 million, we did a great job last year because our expenses were only such and such. And, and our previous year was such and such. So we can combine this year with the previous year. We can then get some insight. Our business has been growing. Our business has been staying the same, or our business has been declining. All right. We can get data by sorting the data and kind of closely associating with sorting is grouping the data together. So like if my $100 million company, if we decide, gee, we're doing pretty good because we only sold $80 million worth the year before. Well, does that mean that every district in the company did a good job? No, there may be company districts within the company that did a great job, all right, and doubled their sales. And there may be other districts within the company where the sales actually declined. So taking that and breaking down totals by sorting and grouping and subtotaling is another way that you can take and transform that raw data into information, something that can be used. I'm sure we can think of other ways, but these are all the kinds of things that you can actually do, bringing us back to our project, through LINQ. All right. We've already seen how you can include data from other places. All right. Now, I hope that was a good refresher for you on this topic. Now let's talk about your project and let's talk about the Contoso University. All right. So we have all of our screens that allow us to enter the data. That's good. They do have some other features, and we'll examine some of those features that are pretty cool too. But I mentioned before, focus on the output. Focus on the information that you want to derive from the system as opposed to the raw data. So I'm thinking of ways that if this were my project, what I might do. All right. If this were my project, I might break things down to having course entity, enrollment entity, student entity, and faculty entity. I guess that's most of the entities anyhow. All right. Throw department in there, and I think that's everything. So, okay, we have those as our entities. Now, what output would make this Contoso University more meaningful? Let's run it and see. Here's a list of courses. How meaningful is that just as a list of courses? Not terribly meaningful. What are some ways we could make this more meaningful? Well, we could group things by department and show economics first, engineering second, English third, mathematics fourth. We could allow you to choose the department and show all the courses just for that department. That'd be another way we could make this meaningful. Because then if I wanted to take a math course, I wouldn't have to sift through all the courses. Now, we have like maybe 7 or 8 courses here. Could you imagine in a larger university there'd be hundreds of these courses, right? So it would be nice if we could search for the course. Think about if you were registering for a course, how you would want to search for it. All right. Now, again, there's factors that aren't in this database, like when the course meets, what time it meets, and so on. But let's say you just wanted to identify what math class you want to take, or what programming class you want to take, or something like that. To be able to break it down by department would be something that would be very useful for you to do. For administrators, what might be useful? It might be useful for administrators to see courses that are full. All right, we'll make a very simple assumption and say that each course can have a maximum of 30 students. Well, it'd be great to see what courses were full. All right, because then maybe we run the second section of a course. Or maybe we increase the capacity for that course or something like that. It might be good to see the low enrollment courses because, as you know, sometimes if a course is low enrolled, we would be able to, we would need to cancel the course. It'd be nice to see, and this is something I definitely know is done here at LC. If there's a low enrollment course, they will look to see what students are enrolled in the course that's low enrollment. And they will contact the student and find out, can we substitute another course for you? Is this something you need for graduation? And so on. So being able to filter this by number of enrollments and either show above a certain number or below a certain number would be very useful as far as that goes. So if I was doing this and I wanted to make meaningful output, and I wanted to focus on information and not raw data, I might add some things to the courses option, or I may have a separate option for course reports or course reporting. And maybe that would include low enrollment courses. Maybe that would include courses by department. And maybe it would include high enrollment courses. So the same data, but we'd be gathering some information from it. All right. It would be nice to produce schedules and rosters from this and not just have a raw dump of all these things. So in other words, for a student, show the student what their schedule is this semester. What are the courses that they're enrolled in? To show for an instructor, what is their schedule this term? What are the classes they're teaching? And then finally show for a given course, show the roster for that course. So if your project just allows people to enter data in and doesn't do any processing of that data to produce something that's useful, then it's not going to get full credit. It's going to get some points deducted because it's not useful. It's just a mechanism for gathering and storing data without producing anything that sort of gives insight into the problem that you are trying to address. So every one of you in your project should be thinking like, okay, I have these tables, however many they are. I can enter data into those tables. That's fine. That's a starting point. The next point, though, to kind of close the loop is like, how can I present this data in a way that will be useful to someone actually using this system and getting the output that they want? All right. And I would hope that everyone could think of that for your particular project. All right. If not, contact me and we can discuss your project and discuss what are ways to make that useful. I don't remember off the top of my head the students' projects that are in here today, but I do remember all of them that I did read. I remember the range of different things. And again, every one of those you can take something and you can take that raw data and produce something meaningful for them. Okay, that's a long introduction. The introduction is going to be longer than the lecture today, I think. I decided that one thing that would help this, and let's say this was my project, would be to provide a course roster. Just a simple thing that could be printed out for the course. All right, details doesn't show it. And the roster looks like this. It shows the name of the course, the department it's in, the instructor or instructors. The way this is set up, a given course can have multiple instructors, and then a list of the students. Now, again, this only has a little bit of data in it, so these aren't going to look great as rosters, but for each one of these, it shows course, the engineering, the department, and the people that are teaching the course, along with a list of students that take it. I did this two different ways, and the one way I like vastly more than the other way, but I will show you both. I'll probably spend more time on the first method, though. We look at this, produces the same output. The way I did it differently is this one uses the method syntax for LINQ. This one uses the query syntax. And again, my take on this is I prefer the method syntax. The query syntax seems to me as more of a concession to people that were used to doing a lot of database work, and it made their life easier. And it eased the transition into using LINQ. All right, so let's look at this. I have roster one, or roster and roster one. Here's the CS HTML file. Here is the CS file. Let's start, as always, with the CS file, because the CS file is where we gather the data needed to produce the page. And I don't like the way that, well, I would prefer, and I don't know if I did this or if the scaffolding did this. I like putting all of my attributes of the model up at the very beginning. I'll delete this one. Okay. So I have all my attributes at the beginning, and these attributes are available throughout this class, so throughout the code behind, and it'll be also available in the CSS_HTML page to actually do the displaying of the page. Now, there's a get sync, on get async. There is no on put. All right. I want you to think about that for a second. It's one thing that I kind of miss in these remote classes is there does seem to be a little less interaction between students and me. But just think in your mind, and those of you that are watching the recording, feel free to do that too. Why do you think there's no on put here? All right. There's no on put here because we are never posting data, or I'm sorry, on post. I kept saying on put, get and post. There's no on post method here because we're not posting any data to this page. Every time we access this page, it's simply by clicking a link. And that link, if you notice, contained an ID as part of the URL. Let's run that and show that. Yes. We look at the status. It says courses/roster $ID equals 1405. That is the ID of this course. And we go down the line. And we can see that when we click on it in the query string. Why do we need something on the query string? Because we want a specific course. This roster is not a roster for every course on campus. This roster is the course roster for a specific course. Therefore, we need to describe what course we need. And in database terms, we need to provide the primary key to it, which is the ID. Now, we're gonna do that on the query string, but that's different than posting data to it from a form. Submit data to it. If we had a query, for example, that allowed us to maybe search by course name and display the rosters of all those courses. I don't know, it's kind of a bad example, but if we had something like that, then maybe we would post form data to this page, but we're not. Okay, so in our onGet, we have, if the ID is null, return not found. Right? If we don't specify who the ID is, what the ID is, then we got an error. Right? Can't pull up a course's roster if we don't know which course you're talking about. So if there's no ID, we're going to return not found. Now we have this statement here. All right. Let's take this one step at a time. This actually has a little bit of redundant stuff in it, and I'll show you where it's redundant. Course equals await, context courses. This gives me a list of all the courses in the database. And what does it give us for them? It gives us all the course attributes. It does not give us any of these lists. So what we're doing is we're building up that list of courses. And we initialize that list of courses as being a list of all the courses from there, but just the course data. This where clause tells me what course I want. So I want a course when that course ID equals the ID that gets passed in the onGet, the ID that's part of the query string. So now we have filtered that list of courses to just the one course, because by definition, there ought to be only one course that matches a given ID, because that's the primary key. Now we're filling in those related tables, because right now we have a list of the one course that we've selected, and we have these fields for it. We don't have these fields for it. Well, we're going to fill those in. How do we fill them in? We say include department. That fills in this. We say include instructors. That fills in the list of instructors. I use collection or lists synonymously. There are differences between collections and lists and so on, but they all mean a group of more than one or potentially more than one. Include enrollments. So at this point, we have for that one selected course, all the course fields, and we filled in department, instructors, and enrollments. But there's one more thing we need, right? Because with the enrollments, we don't get the student name, right? We get the student ID, but that's not useful in a roster, right? So we have one more that says, then include as student. What that means is that we fill in the student entity in the enrollments. How do I know that? Because then include is after this include. So that means from the enrollments, we fill in the students, the student information. Now we should only have one. But in order to prevent some nullness, there's a function that says, give me the first or default value. So there's only going to be one, so the first is the only one, unless there happen to not exist, in which case we'd get essentially an empty course. And here's what I mean, there's redundancies. We could probably get rid of this. And it would still work, or we could get rid of that. Can't get rid of both of them, right? Because we somehow have to filter out. Let me just make sure I'm telling you the truth here. Yep, still works. Or you could have that in and omit the where clause. Doesn't hurt to have it in two places. It's just, it's like wearing a belt and suspenders, One should take care of the job. You don't really need the second one. and we're still in business. This is old code that I had when I was working on this. Could remove it. It's probably a good idea once you have figured out your way in a program to delete all the things that you've commented out as you're working through it. I mean, I could understand commenting out things as you're working on it because you don't know if you're going to get it right or not, but once you do have it working, delete all the things that are commented out. Now, if course is null, in other words, we didn't find a course. When could we not find a course? You might think to yourself, how could I have a situation where I can't find the course, right? Because I'm clicking on this and it's giving me the course ID, right? And all the links are for valid courses that are in the database. Well, remember, you've got a URL here. Someone could get clever or cute and type something in which case it tells me that that can't be found. So if there happens to be an ID that's not valid that gets passed to it, it won't get passed to it through our index page, but some other way it could get passed to it. It returns not found. Now, how does the CSS_HTML look? Well, we're pulling the course information, the department information, and for each instructor, we're pulling the full name. These are all in strong tags. Strong tags are not block tags. They're inline tags, which means that each one of these will be bold on the first line, or each one of these labels will be bold on the first line. We then, for each item in model course enrollments, go and display from item is our model course enrollment. So this is an enrollment entity. From the enrollment entity, give me the student. What about the student? The full name. And that will output the name. I just want to spend a minute looking at the other one because cosmetically it does the same thing. It's a little bit of difference in functionality. And I have a feeling I could rewrite this to be a little better, but I'm not going to. In this, we use the query syntax. This fills everything in. This gives us a course, a list of courses, a list of course that only contains one course. And then a list of student first names. And I go and I take and I fill in these attributes: course name, department name, instructors. And these are available on roster 1 when I go and display it. So I wanted to have more fun with LINQ today to show you another LINQ example to do things. If there's something you want to do in LINQ that we haven't done in class for your project, let me know. We haven't, for example, done anything where we display a list of courses and maybe a count of the number of students that are in the course. Not the name of each student, but the count. Well, how do we do that? Well, there's a way in LINQ to do that, right? My main point of this is, again, for your project, 2 big things is get your database design / entity design correct. The second thing is to make sure you're providing meaningful data and not just a place to enter data and spit it back out untouched. Are there any questions? Okay, this is all I had for today. Either we'll see you in lab or we will see you next week. Take care.